Your Postgres database is already storing the answer to that question. You just can't ask it properly. Right now, if you want to find customers who talked about a bad experience, not with those exact words, but with any words that mean that SQL fails you. You write like queries, you try full text search, you get garbage. That is the actual daily problem for thousands of developers sitting on years of production data they cannot search intelligently. And the usual solution is, rip out your database architecture, add a vector database like Pinecone or Weaviate, build an embedding pipeline, keep it in sync with your Postgres data, and maintain two systems forever. A developer named Varma Buddharaju decided that was insane. So he built Pgsemantic. You pointed at your existing Postgres database. You changed nothing. No new columns, no schema migrations, no separate infrastructure. And you get semantic vector search on your data instantly. Here is what that actually looks like in practice. You install Pgsemantic, you give it your Postgres connection string, and you tell it which table and which column you want to search. That is it. Behind the scenes, it reads your data, generates embeddings using a sentence transformer model, and stores them in a way that does not touch your original schema. Then you query in natural language. You type something like users who had problems with delivery and it returns rows from your database that semantically match that meaning even if none of those rows contain the word delivery or problems. It finds the meaning, not just the characters. The difference between that and a like query is not small. It is the difference between a librarian who actually read the books and a librarian who only reads the spines. But here is the thing, let's be honest about what this is and what it is not. Pgsemantic does not turn your Postgres database into a full-featured vector database. It is not Pvector with all its production tuning options. It does not support approximate nearest neighbor indexing like HNSW or IVF-flat, which means at serious scale, we are talking millions of rows, query speed will degrade. It also does not handle real-time sync. If your data changes constantly, new rows are being inserted every second, Pgsemantic does not automatically re-embed those rows. You would need to trigger that yourself. There is no built-in authentication layer, no access controls beyond what your Postgres connection already has, and no dashboard or monitoring. This is a developer tool, not a managed service. If you are running a high-frequency production workload with millions of records and SLA requirements, this is not your answer today. What surprised me was how much of the real world this actually covers. Most internal tools, most small SaaS products, most data analytics workflows, they are not querying millions of rows in real time. They are querying tens of thousands. A support ticket system. A product feedback database. An internal document search. A customer note archive. For all of those, Pgsemantic works right now, today, with no infrastructure overhead. And that is the realistic near-term future here. Imagine this packaged as a Postgres extension that stays resident, auto-embeds on insert, and handles incremental updates. The architecture is already there in concept. The gap is just operational completeness. If the project gets traction and the show HN post got serious attention, someone fills that gap, and suddenly small teams have semantic search on their existing data with zero migration cost. So why does this exist? Because the barrier to adding AI-powered search to a product is artificially high. Not technically hard, but operationally painful. You need a vector database, an embedding service, a sync pipeline, and the budget and time to maintain all three. Most small teams skip it entirely. What Pgsemantic is arguing is that the data you already have, in the database you already run, is enough. You just needed a smarter way to read it. That argument is correct for a huge slice of real projects. If you are sitting on a Postgres database and wishing your users could search it the way they think instead of the way SQL thinks, this tool is worth 15 minutes of your time. The GitHub link is in the description. Next episode, we are looking at a tool that does something similar but for structured data in spreadsheets, and the accuracy numbers are genuinely surprising. Subscribe so you do not miss it.